Hi guys, welcome back. So in this video we'll be preparing a cable schedule of a 100 kV circuit breaker. Okay, so for that we'll need some drawings, and I have already taken the screenshots of the drawing. Okay, so this is trip circuit 1. Alright, so we'll just zoom it a bit. Alright, okay, so okay, so we'll need to give a DC to the circuit breaker. There are two sources of DC coming from the panel, so DC1 and DC2. So first one is DC K1 and second is negative is K2. Okay, and the TB number in the relay panel. So this is the relay panel. Basically this is the relay panel, and this rectangle here is the about the circuit breaker which is in the yard. Alright, so we have the TB number here is 52 TB.4 and 52 TB.5. so that two TBs we need to use for DC. Okay, so we will just note down those numbers: 52 TB4 and 52 TB5 here in the CRP side. 52 TB dash 4 or point 4, anything you can write here. I'll just write dash 4, and 52 TB. I'll just delete the rest of the TB numbers so it will be very clear. 52 TB4 and 52 TB5. Okay, and the ferrule that we'll be using is both sides we'll be using the same ferrule, 1K1 and 1K2. And as this is DC 1 positive, DC 1 negative. Okay, source DC, we'll write here source, SOURCE. Alright, source DC 1 positive, source DC 1 negative. Okay, and we will just do it. We'll be using a 12 core cable. In that 12 core cable we'll be putting the DC closing and trip 1. In the another second in the cable 2 we'll be using DC2 and trip circuit 2. Okay, and cable status, CB status, and then in the next 12 core cable we will be using for indication. Okay, so now you need to find the TB numbers in the circuit breaker. Okay, we will again go to the diagram. Okay, at the last of the I have taken the screenshot of the circuit breaker as well, so you can see. I hope you can see this drawing. You need to so we need to give. So this is the incoming DC that is coming from the panel. I'll just zoom it out a bit. Okay, so this is supply 1 voltage DC, and this is supply 2 voltage DC, means DC source 1 to the breaker and DC source to the breaker. This is the breaker drawing. Alright, I'll just zoom out a bit and show you what it is in the drawing. So on this page you'll find tripping circuit, closing circuit. This is T1, T2, and this is the closing coil. Okay, these are the tripping circuit, closing circuit. Okay, this is the closing coil. This is, I think, anti-pumping device, and this is trip 1, this is trip 2. Okay, so I'll just zoom in again, and so this is the source 1 and source 2. We need these TB numbers. It's for source 1 it's x1.1, x1-1, x1-2. Okay, we will again note that down in our, what was that, x1-1 and x1-2. Alright, x1-1 and x1-2. Okay, this is now completed. Similarly we will find DC source 2. Okay, DC source 2 first we'll find it in the breaker what it is. So in the breaker it's x1-3, you can see it, I'll just zoom in a bit. It's x1-3 and x1-4 for DC source to the breaker that's been given, that we need to give to the breaker. So x1-3 supply DC1, x1-3 and x1-4. okay, now we need to find DC source that's coming from the relay panel. Okay, so we will again go and see where is the DC source 2 coming from. Okay, in the relay panel. So this is the diagram of the DC source 2, and the ferrule that they have used is K51, and the ferrule that they have used is K51 and K52, but we will be using the ferrule 2K1 and 2K2, that is our standard ferrules. And the TB number from where the DC source 2 is coming is 52TB-12 and 52TB-13. okay, we'll just note down these numbers, 52TB-12 and 52TB-13, 12 and 13. okay, now the DC source, both DC source 1 and DC source 2 is completed. Both, you can note it that both will be on the different cables. So this will be the cable 2. okay, from there the cable 2 is started. okay, all right, then again we'll see the diagram. okay, now what else? okay, now we have is, we need to loop this thing. okay, 52TB4 and 52TB6, and that positive will then go through the TNC switch and through the tripping contact of the and through the SCADA. This is, I think, auxiliary relay for tripping the breaker, and also in through 86 operated relay and distance trip relay and LVB retrip and busbar operated contact that will go to the tripping circuit 1 of the breaker for the tripping purpose. So that's called K23, and what TB they have used is 52TB-7 in the relay panel. So we'll update that in our Excel sheet, and that is, I think we'll first see the closing circuit. okay, so the closing circuit here is the closing circuit. I will zoom out it a bit. okay, now you can see it. okay, the closing. okay, so there's one closing positive, that's closing positive that is coming from the first the positive goes to the circuit breaker, and then it goes to the local remote switch, and from there, when the remote and the local remote switch is on the remote, the positive is then extended to goes into the relay panel, and then through the TNC switch it goes to the breaker closing circuit. So our closing positive is K3, and the TB number used for that is 52TB-1. okay, we'll just note down that number. What's it again? I'll see it, 52TB-1. okay, 52TB-1 I'll give it, and the ferrule that we have used is 1K5, and ferrule that we have used is K5 for closing positive. okay, and 52TB-1, and the TB number in the relay panel is 52TB-1. okay, and now in the circuit breaker we'll see what's the closing positive, where the closing positive goes. So we'll see the diagram of the circuit breaker now. I'll go down, down, down. Okay, so you can see here written is this is the closing coil. This is the closing coil. Okay, I'll just zoom it a bit. Now you can see remote close for SCADA local remote. If you can see here closely, this is the closing circuit, basically K21. This is the closing circuit, like this it goes. This is the closing coil. Okay, now so I will zoom it a bit more. Okay, so what happened is to remote control panel, you can see okay, the positive that's coming from the remote close. So the positive becomes J3. It goes to the local remote positive. J3 goes to the local remote switch, and when it is in the remote, the K5 is being extended. It goes to the remote control relay panel, and from that it goes to the TNC switch, and then it comes back to this point here. Okay, so we need to give K21. We need to do the closing here, and the closing positive is this one. So the closing positive means the positive that is coming to the local remote switch. I'll just zoom in it a bit. Okay, so the positive that is coming through the local remote switch and into the relay panel is called as the closing positive, and the TB number for that is X1 dash 21. Okay, and then for the closing it's X1 dash 22, K21. So remember it's X1 dash 21 for the closing positive. I'll just update it. X1 dash in the circuit breaker, X1 dash X1 dash 21 is for the closing positive. X1 dash 21 is for the closing positive. Okay, closing positive is basically enables the remote enables the breaker. So closing positive goes to the local remote switch in the circuit breaker, and the positive is then goes to the control panel TNC switch, and from there it comes again back to the circuit breaker. So if our switch is on the remote, then only the positive will be extended through the TNC switch of the control room, and from that the positive will come back again to the circuit breaker. So this is called as the closing positive. So if you put this local remote switch in the local mode, then the positive won't be extended to the TNC switch in the relay panel, and so we cannot able to close the breaker remotely. So this is done in order to for the safety purpose. When the breaker is in the maintenance mode, we put this local remote switch in the local mode, so that the positive is not extended to the TNC switch in the control room, and so no one can close the breaker from the control room. Okay, we can close the breaker in the yard, that is locally we can close the breaker. So that was our closing positive, and then when it comes back through the TNC switch of the control panel, it becomes K21, that is closing, and the TB for that is X1-22. We'll update that, X1-22 for the closing X1-22 for the closing, and the ferrule that we'll be using is K21. And in the relay panel, now we'll check in the relay panel what where the where the closing positive and where the closing positive and closing is coming. So in the relay panel, okay, here is the closing circuit. So the closing positive is coming to 52 TB-1, and then through the TNC switch, through the interlocks, then the closing is extended from the TB number 52 TB-2, K21 52 TB-2. So we'll just 52 TB in the relay panel, it's 52 TB-2. Okay, so till now it is clear. Now we'll go with the trip circuit 1. Alright, trip circuit 1 is, this is the relay panel drawing of the trip circuit 1. So what happens, we'll loop this thing here, and then what we'll do is, for tripping it is K23 through the TNC switch or to the master trip relay, the pulse goes to the trip circuit 1 of the circuit breaker. So that is called K23, and the TB number used in the relay panel is 52 TB-7. We'll update that in our schedule, 52 TB-7, 52 TB-7, and we'll use the ferrule K1 K23 1 K23, and now we'll check the TB number that is in the circuit breaker. Okay, so for that we'll circuit breaker. Okay, so TC1, so we'll zoom out a bit. So here it's this is the tripping coil. So this is the tripping coil. Negative is being continuously given to the tripping coil, and the positive that's coming from the remote for SCADA for protection trip. Here this TB for protection trip, this is for the protection trip K23. So this is the TB number that we are looking for. We'll connect the cable coming from the trip circuit 1 from the relay panel to this TB in the breaker protection trip. We'll be using this protection trip. Okay, so that's it. That the TB number is X1-11 for K23. So we'll update that in our schedule. X1-11 for trip circuit 1. Trip circuit 1. Trip trip 1. We'll write as a trip 1. We'll write as trip 1. We'll write is as trip 1 protection trip. Protection trip 1. We'll write is at protection trip 1. We'll write it as protection trip 1. Or we'll write it in bracket protection. PROTECTION, protection. We'll write it as protection, trip 1 protection. Now there's something called as pre-close, post-close and pre-close. So that is used for monitoring the healthiness of the tripping circuit. So they have written it here, the post-close and pre-close. So what it does, it monitors the negative coming from the pre-close and post-close. It monitors the negative that comes through the tripping coil and through the auxiliary contact. When the breaker is off, 52 dB is on, and it goes to the trip circuit supervision relay that are placed in the relay panel. Okay, so this is when the breaker is off, it's called pre-close. When the breaker is on, this contact closes, and it's then called as post-close. So we will enter first in the breaker off condition. We will pre-close. That's the TB number is X1-13 for pre-close. X1-13 pre-close. We will take it first. X1-13 is for pre-close. Trip 1 pre-close supervision. pre-close supervision, supervision, pre-close supervision. And in the breaker it's x1-13. Now we'll see what it is in the relay panel. Okay, so in the relay panel we'll open the diagram of the relay panel. Okay, we'll just zoom it in. So this is the pre-close supervision that is coming from the circuit breaker. So through the coil of the closing coil of the relay, negative is coming through the closing coil of the relay, and through a close contact when the breaker is off, it's called pre-close. It's given to this coil of the relay here. Okay, and the other end of the coil is given the post-close supervision. Okay, and then K23 is given to this coil, and positive is given to this coil. So one of these two, 95A and 95B, one of them should be continuously on, which indicates that our tripping circuit is okay. Okay, so now we wanted pre-close TB number. It is 52 TB-8. We'll go to the schedule and we'll update it up. 52 TB-8. 52 TB-8. Now we'll go for trip 1 post close supervision in the circuit. It's called 1K23AA. Pre-close is called 1K23AA. Now we'll go with post close supervision. Post close supervision is given here. Okay, its ferrule is K23A and its TB number is 52 TB-9. 52 in the relay panel. 52 TB-9. 52 TB-9 we will mention here. 52 TB-9. And in the circuit breaker it is, we'll see what it is in the circuit breaker. In the circuit breaker, the post close TB number is post close TB number is x1-12. Okay, so we'll update that here. x1-12 is for the post close. x1-12. Similarly we'll do it for the similarly we'll do the tripping, and similarly we'll do for trip 2 DC. We have already given the TB numbers. Now we'll use a second cable. We'll be using a second cable for trip 2. Okay, so just we'll mark this cable 1 into some red. Okay, so this for, okay, so this 6 1 2 3 4 5, this is the 6th one, and this is the 7th one. 7 cores we have used from the first 12 core cable, and now we'll start with second 12 core cable. We'll be use second cable for the DC2 for trip circuit 2, because we need to keep separate trip circuit 1, trip circuit 2, because if any one of the cable gets faulty, the tripping will be extended through the other cable. So we need always will keep the separate cables for trip 1 and trip 2. Okay, so now we'll see. Okay, so now we'll see about the tripping trip 2 and pre-close and post-close supervision in, and the pre-close post-close supervision in trip 2. Okay, and I think we will also keep the CB status in in the second 12 core cable, because a lot of the cables okay, we'll see how it goes. We'll go for the trip 2 TB numbers in trip 2 TB numbers in the circuit breaker first. So here it is, trip 2. So here it is, this is the trip 2 52 T2, this is the tripping coil 2, and we will protection trip used is X1 16, and pre-close is X1 18, and then its post-close is X1 17. So we will update the CBTB numbers. X1 what it was, X1 16, 18 and 17. Okay, 16, 18 and 17, 16, 18 and 17. Okay, this was the trip 2, and now we'll check it in the relay panel what the TB numbers are for the, what TB numbers are used for the trip 2. So this is the trip 2, and the TB numbers here used for protection trip is 52 TB 15, and then pre-close it's 16 and post-close it's 17. So it's 15, 16 and 17. It's 15 for trip 2, 15, 16 for, we'll take pre-close first, 16 for pre-close and 17 for post-close. Okay, 12, here it was 7, 8, 9, here it is 15, 16, 17. Okay, and the core that we have used is 1 for DC2, 2 second for DC2, third for trip protection trip 2 protection, trip 2 protection, and then fourth is for pre-close, and fifth is for post-close, trip 2 post-close. So only 5 core of the 12 cores are used. Ideally we should be using a new cable for CB status, okay, and then new cable for indication, but I think we will club this CB status with trip 2, or shall we put a new cable? Okay, okay, I think we will club this cable with trip 2. So it will become 5, 6, 7 and 8 cores, then 8 cores will be used. We'll just cable 2. And we will just highlight it like cable 2, will highlight it blue color, we'll give it a blue color. Okay, so this is the cable 2. Now we need to find out the CB status KX1, CB status positive, CB on and CB off. This this is to operate an auxiliary relay CB on and CB off. Okay, so we'll check it in where it is in the relay panel. Okay, so CB status. Okay, so this is the CB status. Hope you can see it. CB status positive. Okay, so CB status positive. No, this is closing circuit. This is the CB status. So positive, we give it is KX1, and then it is given to 52 TB 20 in the relay panel. Okay, and this is positive 52 TB20, and then when the circuit breaker is in the off position, then the positive will come to 52 TB21. Okay, when the circuit breaker is in the off position, the positive is coming here. But okay, now they have shown the circuit breaker is in the off position. What they have done, I'm getting a little bit confused here. I'll just see the breaker drawing. Okay, so this is the breaker drawing, and what we need to use is for a breaker. Okay, you can see here this status is they have used the auxiliary contact in the tripping and the closing circuit. They use the auxiliary contact in the tripping circuit. So the breaker is in the off position. When the breaker is in the off position, 52B contacts are closed. Okay, so 52B contacts are closed. So these contacts we can use for these contacts we can use for breaker open status, when the breaker is in the open. So what the diagrams they provide is for breaker in the open condition. So 52B, this contact will use for the breaker open condition, and then we'll see breaker open condition is closed. So this is the open condition, and I think they should have shown this contact as closed, so that when the breaker is in the off condition, the positive is being extended to here. This is in the normally in the reset condition. So we need to operate it first. So they should have used a close contact here. So when the breaker is in the off condition, when the breaker is in the off condition, the relay is not operated. So when the breaker is in the off condition, this contact is closed, and so positive is extended here. Okay, so we'll note down this TB number 52 TB 20 and 52 TB 21 for breaker off condition. 52 TB 20 is for positive, KX1, 52 TB 20, 52 TB 20, and for CB off condition, CB is in the off condition, it's 52 TB 21, it's 52 TB 21, and the ferrule we'll be using is KX19 for off, and KX21 for on. KX19 and KX21, KX19 and KX21 for CB on. Okay, now we'll find. Okay, and CB on. When the CB will turn on, this contact will close, and the positive will be extended, and the positive will be extended. This coil will be operated. Okay, and on this coil will be operated, and the status breaker on is extended to this BCU circuit, distance protection, indication circuit. Okay, all these places the signal will be extended. Okay, so now we'll see what points are given from this circuit breaker. Okay, so we'll open the circuit breaker contacts. We'll use the pair contacts for the CB on off status. So these contacts are shown when the breaker is in the off position. So we will need one contact. We'll use one contact, close contact, for the breaker off position. So it's 52 TB. So it's 52 TB. Okay, it's x3 x3-3, and the other end is x3-4. These 2 points will be using for breaker off status. 53 what's it is, x3 dash 3 x3 dash 4 x3 dash 3 x3 dash 4. It's x3 dash 3 x3 dash 3 for CB status positive and CB off status, and x3 dash 4 is x3 dash 4 is CB off status, status. Okay, and CB on status. And now we'll see for the CB on status. CB on status will use an NO contact. When the CB will be switched on, this gets closed and then positive is extended. So the positive this and this will be looped, and positive is given to this one, and this TB will be looped, and then when the CB is on, the positive will be extended through this TB. x3 dash 2 x3 dash 2. Okay, I'll just write it down. x3 dash 2 in the circuit breaker. It's x3 dash 2 in the circuit breaker, x3 dash 2 in the circuit breaker, and in the relay panel it is and the relay panel for closing, is 52 TB 22. 52 TB 22. 52 TB 22. Okay, so now 2 cables are completed. Now we will go for the indication. Okay, indication will be using a different cable. That will be using another 12 core cable, and we'll be using again the red color here, and it's cable 3, sorry, it's 12 core cable 3. Indication, first we'll need indication positive. Let's see then what other things are there. Okay, so indication will search what things are there in the relay panel first. Okay, so indication point of view, so this is the indication. So this is the indication that we have used here. Okay, so the common that we give, so the common positive that we need to give to the breaker. So this is the breaker and this is the relay panel. We need to give a positive indication, positive to the breaker. Okay, so and that is KX1, and okay, so that's KX1, and the TB number is 52 TB 27, and negative is KX2. KX1 will write 52 TB dash 27. KX1, it's KX1, KX1. I think they are using KX1 for indication positive. KX1 for indication positive, so we'll club that with this cable status with this indication. Okay, so no problem with that. KX1 is used for this. Then in the relay panel it's 52 TB 27. Now loss of SF6 indication is 52 TB 28, and the ferrule used is KX71. 52 TB 28 KX71. 52 TB28, 52 TB28, 52 TB28 KX, and the ferrule that they have used is KX. I'll just check once again. The ferrule that you have used is 52 TB28 KX71. Okay, it's KX71, KX71, loss of SF6. Alright, and okay, loss of SF6. Then again we'll see what else is there. SF6 low lockout means the breaker will go into lockout mode. That's it. 52 TB29 and KX ferrule is KX73. 52 TB29, 52 TB29, 29, and ferrule is this KX73, KX73, KX73. Okay, that's loss of SF6 lockout, loss of SF6 lockout. Loss of SF6 lockout. It's loss of SF6 lockout. Loss of SF6 LOCKOUT. Loss of SF6 alarm and loss of SF6 lockout. Okay, let's see what it is. Next is CB AC supply fail. Okay, CB AC supply fail. CB AC supply fail is on TB number 52 TB30 and KX75. 30 and 75. It's 30 and 75. 30 and KX75. KX75 CB AC supply fail na. CB motor AC supply fail. CB AC supply fail. Okay, CB motor AC supply fail. CB AC supply fail, and after that it's CB spring charge. It's 52 TB31 KX77. 52 TB 31 77. 31 and 77. 31 and 77. 31 and 77. Okay, spring charge. CB spring charge. Okay, CB spring charge. CB spring charge. Okay, CB spring charge. What else? Okay, only this many indications are there. Okay, and the breaker on off. Okay, so only this many indications are there. Okay. Okay, now we'll see the same indications in the breaker, what the ferrule numbers are used, and the rest of this we can delete, we don't need it. Okay, so indication positive only we need to give. Indication positive. So we'll check the circuit breaker diagram now. Indication positive. Where do we need to give the indication that's required for I think we don't need to give a separate indication positive, because they've used the same. They've used an MCB, I think DCC DCC1. They've used something like this. Same they have used. They have derived it indication positive. They have derived the indication positive. I don't know what they have done here. DC changeover circuit. This is the DC changeover circuit. They use the same DC for that. I need to check if from where the indication they have taken in the breaker. I'll just check where the indication they have used in the breaker. So this is the breaker drawing. Okay, so here it is. Low gas pressure, motor supply fail. Okay, I'll just take a screenshot of this. And I'll paste it in our notepad. Okay. Okay, and I will just again. Okay, so this is the indication that we have indication. So we'll start with low gas pressure alarm. So for that they have used X1, X2, X2-1 and X2 dash. So positive will come. So positive will come from indication positive KX1. So indication positive will come to this this TB here X2-1, and this will be looped with this X2, X2-2, X2-4. Okay, so indication positive will come here, and then this will be looped with X2-3. This will be looped with X2 again. These things looping will be there. Okay, so indication positive for low gas pressure alarm is X2-1 and X2-2. It will be coming out. Okay, so indication positive will go to X2-1. It will go to X2-1. Then we'll first do the looping here. Indication positive will go to X2-1 dash also, and looping will be done to X2-3. Okay, X2-1. Okay, indication positive. Indication positive will go in CB. In the CB it will be like X2-1. In the CB it will be like X2-1, X2.1. We'll keep it X2.1 dash X2.1 dash. Then it will go to X2.1. Then it will go to next is here is loss of SF6 na. So it will loss of SF6 X2-1. First one is loss of SF6, second is loss of SF6 lockout. Okay, low gas pressure lockout. Then it will go to x2 dash 3. The loop will be go to x2 dash 3, x2 dot 3, and then the same loop will go to CB motor AC supply fail. The same will go to CB motor AC supply fail, because the same in the relay panel diagram we have seen that they have made the same positive indication positive for all of these. CB motor supply fail and everything, they have used the same CB motor supply fail. So we'll combine this common positive with x2, we'll combine this common positive with this one, and from there this one x2 dash 13, x2 dot 13. Okay, x2 dot 13, and then let's check what it is after that. Then it's spring charge, closing spring charge. Okay, closing spring charge. Okay, then it's x2 dash 5, x2 dash 5, x2 dash 5 dash x2 dot 5. Okay, so we have covered here in this. We have given positive to loss of SF6 alarm, loss of SF6 lockout, then CB motor AC supply fail x2 dash 13, then CB spring charge x2 dot 5. Okay, all right then. Now the other end we'll write here, the other end of this contacts will write here. Okay, so loss of SF6 is, okay, so loss of SF6 is x2 dash 2, sorry, loss of SF6 is x2 dot 2. We'll use dot convention, dot x2 dot 2, x2 dot 2 for loss of SF6. For loss of SF6 lockout, it's x2 dot 4, x2 dot 4, x2 dot 4, and then AC supply fail, motor AC supply fail, then motor AC supply fail x2 dot 14, x2 dot 14, and x2 dot 14 and CB spring charge. For CB spring charge it's x2 dot 6, x2 dot 6, x2 dot 6. Okay, so whatever, okay, so the cable, so we'll see the relay panel diagram once again. Okay, so this is the relay panel diagram. So the common was 52 TB 27, 52 common positive that went into the yard was 52 TB 27, 52 TB 27. I'll just write it down here, 52 TB 27. Okay, and so these many, okay, so these many contacts, so these many indications have been covered: loss of SF6 lockout, AC supply fail, and CB spring charged. Okay, so but there are some more. Okay, we'll once check the panel drawing if there are anything more indications, circuit breaker indications that we have used. So these are the only indications that they have used in the scheme. Okay, so but our circuit breaker is offering some more indications here that we can use. Circuit breaker is offering some more indications here that we can use it. Okay, that we'll wire it up, and in the future we can use those contacts for anything else, anything we need. Okay, so that indications are motor heater and illumination supply fail, heater and illumination supply fail. I don't think we need this indication. DC supply fail. Okay, this thing we can use, we can wire it up. DCC2, DCC1, DCC2 and DCC1, DCC2 and DCC1, DCC2 and DCC1. Spring charge circuit, SF6 gas pressure lockout, breaker on indication, breaker off indication, breaker spring charge indication, DCC1, DCC2, DCC1, DCC2. So these contactors are given, they check the DC supply of the breaker. So we need to wire it on the spare, if indication spare annunciator is there, spare contacts, we'll wire it up somewhere in the scheme, DCC1 and DCC2. So we'll give our but we'll need an auxiliary relay for that. Okay, so positive will extend here and the same positive will extend here. We'll need an extra auxiliary contact. That we can use auxiliary relay for DC supply failure. Okay, they've used, okay, we'll wire it up or directly on the annunciator. Okay, so we'll need to give the DC supply from the annunciator. We need to give the DC supply from the annunciator, and if you're using the DC supply from the annunciator, we need a different cable for that. Okay, we will be using the CB status in the same cable because the DC is same, KX1. Okay, so I'll just convert it into red color here, and this will use it as cable 3, cable 3. This is 1, this is second core, this is third core, this is fourth core, fifth core, sixth core, seventh core, and this is the eighth core. So 8 core we are using from the third 12 core cable. Okay, so we'll just use this cable, cable 2 for wiring up initiation uh, indication, but we'll just keep it on the wire on the spare TB. Right now we'll just use it on the spare TB here. On the relay panel we'll keep it on the spare TB, spare 1, spare 2, spare 3, and we'll give it common. In the breaker it's x2, x2.9, x2.11, x2.9 and x2.11. In the breaker it's x2.9 and x2.11. In the breaker it's x2.9, 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 x2 dash, x2.9 and x2.11. okay, and for DCC2 DC supply fail, DC supply 1 fail, it's x2, x2.10, and for DC supply 1 fail, it's x2, x2.12 and x2.10, x2.12 and x2.12 and x2.10, x2.10. DC supply fail positive, DC supply fail positive, it's DC supply fail indication positive, indication positive, DC supply fail indication positive, and DC supply DC1 fail indication, DC2 fail indication, and we'll just turn it into blue because we are keeping it in the cable 2. So this is number 6, this is number 7, this is number 8, and the ferrule that we are using it, and the ferrule that we will be using is it's L10 and then L11, L13, L10, L12, L11, L13, L12, it's L12, L11 and L12. L12 is for positive, L12, L13 and L11, L13 and L11, DC2 fail indication. Okay, so we'll just wire it up on the spare, and then afterwards we'll see if we can use it somewhere on the enunciator or in the SCADA, somewhere we can use it, then we will definitely use it. Okay, so this, now that we have, okay, now we have completed this 3 cables, cable 1, cable 2, cable 3, 12 core cables, 3 12 core cables we have laid. First 12 core cable we have used it for trip circuit 1, second 12 core cable we have used for trip circuit 2, and third 12 core cable we have used it for indication purpose. Okay, and now what is remaining is AC cable to the motor. We need AC to the motor supply. We'll then again check in the that comes from the ACDB, so we'll check the circuit breaker where we need to give the AC supply to the motor. Okay, so it's x1.5 and x1.6. h1 is 2, x1.5, x1 x1.5 and x1.6. okay, it's is phase supply and the neutral supply to the motor. And for the heater and illumination, we will, it's x1.7 and x1.8, x1.7 and x1.8, x1.7 and x1.8. okay, and it is given from the ACDB in the yard. Okay, the ferrule that we'll be using is H1 H2 and H3 H4, same thing. H1 H2, H1 H2, H3 H4. okay, we'll be using, what we'll be using, we'll be using 4-core cable, 4-core colored code cable, 4-core colored code cable. It's cable 1. Another 4-core cable we will be using for cable 2, will be using for illuminator purpose. Okay, okay, so we need to do some looping, looping in the major, in the breaker, like we did this indication looping. Similar, we need to check if there is any indication looping that we need, other looping that we need to do in the breaker, okay, or in the relay panel. All right, so I think we need to do indication looping for this CB status. Okay, we'll just check the CB status. CB status, no? CB, for CB status we have used these two contacts, no? So we need to do positive, we need to give in x1 dash 3, and we need x1 dot 1, and we need to loop it with x1 dot x3 dot 1 and x3 dot 3 okay. So for breaker off we have used this contact, so we'll give DC to this TB first. x3 dot 3, x3 dot 3 we have already, x3 dot 3 will use x3 dot 3, and then we will loop it with x3 dot 3, will loop it with x3 dot 1, x3 dot 1, x3 dot 1. okay, and then it is given to x3 dot 4 and x3 dot 2, x3 dot 4 and x3 dot 2. okay, and so this looping is over, indication looping is over, then DC fail looping is over. What else is remaining? Just we'll check if there is any looping there in the relay panel. I think there is one looping. Okay, so there is this looping here. If it is not given internally, then we will have to loop this loop here, and also we need to bypass some contacts, like say this auxiliary contacts of the isolator. We don't use those contacts, auxiliator. Okay, so I think mostly our schedule is completed now and ready to give this schedule to the technician who will be wiring this. Thank you so much. I'll just putting this diagram in the LinkedIn, so please do follow me on the LinkedIn. Search for Nitin N, or protection and automation engineer. Thank you so much.